Okay, let's go over this problem-solving problem number 6. So let me say a few of the things that I noted that students had issues with. First, individual numbers are either increasing or not. It's not that a sequence is increasing or that if I have a number and then a different number, I compare them about increasing. Individual numbers are either increasing or not. For example, 589 is increasing because 8 is greater than 5 and 9 is greater than 8. 3,679 is increasing, 6 is greater than 3, 7 is greater than 6, 9 is greater than 7. 903 is not increasing because 0 is not greater than 9. And 557 is not increasing because 5 is not greater than 5. An important realization about this problem is actually that an increasing number can't have repeated digits. So the same number can't appear twice in an increasing number because it wouldn't be getting larger. Lots of ways you could figure this out, and this is what I want to spend a little time on, is how could we possibly figure out how many of these there are? Well, let's look at what they start with, and let's not start with 1, because there's a bunch of them for 1. But let's start with 9. There are no increasing numbers that start with 9, because after 9, there's nothing I can write, and single-digit numbers don't count. 8, there's just 89, so that's 1. For 7, there's 7, 8, 7, 9, and 7, 8, 9, so there's 3 of them. For 6, there's 6, 7, 6, 8, 6, 9, 6, 7, 8, 6, 7, 9, 6, 8, 9, and then 6, 7, 8, 9 is 1, 2, 3, 4, 5, 6, 7 of them. Let's see if I can do 5. For 5, there's 5, 6, 5, 7, 5, 8, 5, 9, 5, 6, 7, 5, 6, 8, 5, 6, 9, 5, 7, 8, 5, 7, 9, 5, 8, 9, 5, 6, 7, 8, 5, 6, 7, 9, 5, 6, 8, 9, 5, 7, 8, 9, 5, 6, 7, 8, 9. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, at this point I can probably see a pattern, or at least I could guess. I would guess the pattern is if I go from here to here, I double and add 1, double and add 1, double and add 1, double and add 1. So 6 should be 15 times 2 is 30, so 31. 7 should be 63. 8 should be 126. Nope, 7. And 9, I went the wrong way. I always go the wrong way. 4, 3, 2, and then 1 should be 255. If you add all those up, you get the right answer of 502. Okay, so here's just me showing that work again. So as we go down, we get more and more. Here's actually the full list for 4 and 3 and 2 and 1. There they all are at the bottom with 1. They're all 255. So there, if you add them up, you get 502. But notice we only need to do a little bit to make an inductive guess as to what's happening with the numbers so we could get a guess at the answer without listing them all out. Another way you could do this is organize them by length, and let me just go through that argument quick too. So if you start with 2-digit guys, well, you just need to list those out. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, and then 2, 3, 2, 4, 2, 5, 26, 27, 28, 29, 34, 35, 36, 37, 38, 39, 45, 46, 47, 48, 49, 56, 57, 58, 59, 67, 68, 69, 78, 79, and 89, which I actually have on this next slide. Okay, there those all are. Now, if I want to get to 3-digit numbers, I can actually look at Well, what three-digit numbers would start with 1? The three-digit numbers that would start with 1 could be, starting from my list here, I could put 1 in front of all of these 2 numbers, giving me 7 new that start with 1. 1 in front of all the 3s, so 6 more, 5 more, 4 more from the 50s, 3 more from the 60s, 2 from the 70s, 1 from the 80s. So there's 28 new ones that start with 1 in 3 digits. Starting with 2, I can do the same kind of thing. Oops, that was definitely not the right button. So starting with 2, I can put 2 not in front of these guys and not in front of these guys, but I could put 2s here. So that gives me 6 more, and then 5 more, 4 more, 3 more. So I can get 21 more numbers that start with 2. And then 3 is the same idea. I can get 15 of them, 10 more 4s, 6 more 5s, 3 more 6s, just 678, 679, and 689, and then 1 7, 789. Then I can repeat that idea. So going to 4 digits, I can have 56 that start with 1, because I could have put a 1 in front of all the 2s, in front of all the 3s, in front of all the 4s, and so on. And just continuing this idea, I can slowly count up. It actually tops out at 126, because now that I'm at 6 digits, to put a 1, I only get 35, 15, 5, and 1, so only 56 more, and then 21, 6, and 1. But continuing this pattern, continuing this idea, all the way up to the 9-digit number that starts with 1, I get these numbers. I can add them up for 502. Here's another way you could do it. You could have written a computer program. Here's a crummy, not optimized at all Python program I wrote that takes forever to run. But it just simply takes a number, looks at the last 2 digits. If they're increasing, it chops off the last one and then runs it again to see if the last 2 digits of the new number are increasing. And after it's done checking, it goes to the next number. I ran this for, let's see, between 1 and 1,000, there are 129. Between 1,000 and 10,000, there are 252. Between, oh sorry, that wasn't 10,000, it was 100,000. Between 100,000 and 10 million, there are 120. If you add that up, it's 501. The only one it's missing is 123,456,789. But running between 10 million and 100 million would take much longer, okay, than it took to do the work I had so far. And Python's not a super fast language, so you'll just have to trust me that one extra one that it didn't count is there. If you looked this up online, so you used your outside resources, this is likely the way you saw to solve it. This is the way I did in my video, so if you look at that set, every non-empty, non-single digit subset is an increasing number, or can be written as an increasing number. There are 2 to the 9th, 512 subsets, minus 1 for the empty set, minus 9 for the single digit subsets, gives me 502. Okay, always look back. Can you check your result? That's really hard this time. So unless you had a firm pattern going in and you could see that it repeated in certain ways, checking your results hard. You almost have to do it again or do it a different way. Like I said, can you drive it a different way? Could you do it a different way? Can you use this on other problems? Okay, have you learned anything new? Do you know you're right? What did you get out of doing this problem?